There is a star in our galaxy that sounds like it should not exist, not because it is huge, not because it is exploding, not because it is swallowing planets, but because, on paper, it has sometimes seemed to be older than the universe itself. That sounds impossible, because if the universe began around 13.8 billion years ago, then nothing inside it should be older than that. Yet one of the most famous ancient stars ever studied, HD 140283, often called the Methuselah star, has repeatedly pushed right up against that limit, and in some estimates, slightly past it. So what is going on here? Did astronomers find a star that breaks the timeline of the universe? Not exactly, but they did find a star so old that it started a real scientific headache. HD 140283 is in the Milky Way, only about 190 light years from Earth, which is incredibly close for something this ancient. NASA describes it as one of the oldest known stars ever observed, and says it appears to be almost as old as the universe. That alone would already make it special. But what made this star famous was the age problem. In the early 2000s, Hubble measurements helped refine its distance and age, leading to an estimate of about 14.5 billion years, plus or minus 0.8 billion years. At first glance, that looked absurd, older than a universe thought to be about 13.8 billion years old. NASA even called it an obvious dilemma. But because of the uncertainty range, the star's age still overlapped with the universe's age instead of clearly breaking it. So the real story was never, we found a star older than the universe, case closed. The real story was, why do our best measurements keep getting uncomfortably close? That is what makes this such a good idea, because it is not just a paradox. It is a precision problem at the edge of cosmic history. Astronomers estimate a star's age using things like its brightness, temperature, chemical makeup, distance, and stellar evolution models. Basically, trying to figure out how far through its life the star has already moved. With HD 140283, small changes in those inputs can shift the age a lot, which is why different studies have landed in different places. That is why this star keeps coming back. In 2021, a revised modeling study using updated measurements estimated the star at about 12 billion years old, which removes the paradox completely. That result said the best fitting age was not in conflict with the age of the universe. But then in 2025, a new asteroseismic study, using stellar oscillations to constrain the star, reported an age of about 14.2 plus or minus 0.4 billion years, which again put it slightly above the estimated age of the universe, though only by about 0.8 sigma, not some catastrophic contradiction. The authors themselves frame this as a modeling and precision issue, not proof that cosmology is broken. So no, this star does not actually destroy the Big Bang, but it does expose how hard it is to measure the oldest things in existence. And there is another reason HD 140283 matters. NASA says we know it cannot be one of the very first stars, even though it is incredibly ancient, because it contains metals. In astronomy, that means elements heavier than hydrogen and helium. And those had to be forged by even earlier stars. So this object is ancient, but not the beginning. It is more like a survivor from very near the beginning. That is what gives it this eerie feeling. You are looking at something from almost the start of everything we know. a star born so early in cosmic history that our measurements keep bumping into the age of the universe itself, not because reality is broken, but because we are trying to read the birth date of something unimaginably old. And the closer astronomers look, the more this star becomes a test of stellar physics, a test of measurements, a test of how precisely we think we understand the age of the cosmos. That is why HD 140283 is unforgettable. Not because it definitely is older than the universe, but because it gets close enough to force the question. Close enough to make scientists recheck the numbers. Close enough to make the timeline feel fragile. And close enough that, for a moment, one lonely star in our galaxy can make it seem like the universe itself might have gotten its own age wrong.